Good morning, everyone. My name is Piero, and today we're going to do some science experiments at our home and learn what different things we look for when doing a science experiment. For those of you guys joining us online and will not be joining us live this morning, in order to begin, I need you guys to go grab some apples or any fruit with seeds, really, if you have them at home. Disposable or glass cups, but I'm personally going to be using disposable cups. So cups just like this. A water bottle or 2 water bottles if you don't have a big one like me, and some potatoes. For those of us joining us live, welcome. Today we're going to learn how to conduct some experiments at home and what different things we look for when doing a science experiment. We're going to have an awesome time and it's going to be a lot of fun, a lot of things to learn. We're going to give it a little bit and then we're going to get started. So I gave the list of materials, but I'll give it again. I want everyone to grab some sort of fruit with seeds. So that could be an apple, a pear, a tomato if you want to get fancy and you consider it a fruit and not a vegetable. I'm going to keep it classic and grab an apple. Grab some toothpicks. Good morning, Ed. Some disposable cups and potatoes. Those are the tools we're going to need for today. All right, scientists, let's get started. It's 9 o'clock.
Bill Nye the Science Guy.
And it's time for science.
Bill Nye the Science Guy.
Science rules.
All right. So today, guys, we're going to be conducting a bunch of different science experiments over the premise of can we grow potatoes indoors? So why are we doing different experiments? Well, we're doing different experiments today because we want to know if things can grow, if this potato can grow indoors, and what makes it grow indoors. So it's not simple enough to get a potato and an apple and to see if the potato grows indoors. You need to compare the potato growing indoors compared to something else. So for instance, if a potato could grow indoors and an apple could grow indoors, then there's nothing really too special about the potato because both things grew. But if the potato grew and then the apple grew, that means that the potato is different from the apple. Science is all about comparing stuff. And the reason why we're comparing stuff is because they're different between each other. When two things are different from each other, we call these, in science terms, variables. So it's all about making sure that the variables are what we like to call controlled. So we're going to start our experiment by getting 2 disposable cups. And I want you guys to fill them up with water. So I'm going to be doing that over here, and I want you guys to do it as well. We'll be filling up our disposable cups with water. This is disposable cup number 1. And this is disposable cup number 2. Make sure the cups that we're using are equal because we're trying to see what differences affects growth. So if 2 things are different, then that's what's causing the different results. But if more than one thing is different, then we can't tell what is causing the difference. So scientists have to be very, very careful in making sure everything is the exact same situation, but what they are testing. It will make more sense as we go along during the day. So what I want you guys to do is I want you guys to go and get yourself a potato. I'm going to slow it down a bit because I'm talking really fast right now. I know you guys got to go grab them. Once you get your potato, and this is what I want you guys to be very, very careful with, and maybe the adult scientists at home are going to have to do this part instead of the kid scientists. I want you to get a knife, and you're going to cut the potato right down the middle. Not going vertically, but we're going to go horizontally, just like that. And we should get 2 big halves. Potatoes are kind of tough, so just be careful, guys. Awesome. And then what we have is 2 halves of a potato. Unfortunately, this science experiment is not how to make French fries, but we are going to be doing something with these potatoes. We are now going to take these toothpicks, and we're going to be putting these toothpicks through the potato skins on the outside, leaving this slippery, slimy surface on the bottom. Just putting your toothpicks in the potato. I did 4 toothpicks. The number of toothpicks doesn't matter. It might. So that is another variable we need to consider, and it's another variable that we need to control for. In other terms, we need to make sure that if this potato gets 4 toothpicks, what we're comparing also gets 4 toothpicks. I'm going to see if it's going to work. Yes. And you want to place your potato with the toothpicks on the rim of the cup so that the slimy surface of the potato is facing down towards the water. And then you're going to grab our science apparatus, otherwise known as our cup with a potato on it, and we're going to fill it up a little more so that the slimy surface is touching water. Very, very good. Now we need something to compare this to so that we could grow, or we could have our actual science experiment. Now, what I'm going to be using today is I'm going to be using an apple core. Why am I comparing it? Because I'm comparing 2 things that grow outdoors. Maybe not the best comparison, but that's what science is about. It's about trying to get something and compare it to another thing. But I gotta make sure it's as equal as possible so I can tell the difference between a potato and an apple. So what I will be doing is I will be using the exact same cup filled with the exact same source of water. And I'm going to be using exactly 4 toothpicks. This is an apple core. An apple core has seeds inside of it. So that's why I will be using the apple core. And so I somehow have to use exactly 4 toothpicks. If you do not use an apple, let's say you're using a pear or something with a seed, that is fine. Just make sure what you did with the potato, you do with this one now. And I'll have you guys take a look. We have our apple with toothpicks and water. And now we're going to fill it up with some more water, just like we did with the potato. Very, very good. And now to wrap up the experiment, we need to put these science experiments at a source of light. So I'm going to be creating my own little space over here. And I want you to do the same at home. We'll put one over there. And then we're going to put our second one right beside it with this exact same light source. Now, that is experiment number 1. But we might get lucky. It might be a fluke that something happens, because that happens from time to time. I want people who are watching right now to comment in the chat box of what else can we do that might affect how those things grow. In other words, what we can control for. This one's a tough one. Take your time. If you're watching us at home, think about it yourselves. What can we do that might make the potato grow differently? So I'm comparing a potato to an apple. Because what's the difference between a potato versus an apple? That's what that's going to find out. But let's try to think of something new, a new test, or what scientists like to call a hypothesis. Think about it. I'm going to test the differences between what if I get a potato and one gets light and one doesn't get light. So now I gotta think how I'm going to test this. Well, I could get my potatoes and I could do exactly what I just did last time. Do you mean like adding coloring to the water? That could work as well. You could compare water versus colored water. Maybe colored water makes it grow faster. That would be a great idea, Natalie. So those experiments you could do at your home as well. I'm going to be one comparing light versus darkness. So I'm going to make a potato apparatus like I did last time, get my potato half, and I'm going to put 4 toothpicks in it. I'm going to put the slimy top down, and I'm going to fill it up with water, just like I did last time. And I'm going to place it by a light source. So now, in order to compare light versus darkness, I need to do the exact same thing, but this time, I need to make sure that I don't expose it to light. So I get my potato, cut it in half, get 4 toothpicks, 1, 2, 3, and 4. And then I place my potato on top like I did last time, and I fill it up with the exact same amount of water. But this time, I'm going to place it on the ledge over here. Actually, let me so that you guys could see it. I'll be placing it right over here. And I'm going to be covering it with something that makes sure it doesn't get exposed to light. So it's the exact same thing, except one gets light and one gets darkness. And then we're going to see in a week or two if it grows or not versus that one. Now we need to do that experiment again to test something else. What else can we test? So this is where we think, what have we done that might influence growth? We've done light versus darkness. We did apple versus potato. The next thing I'm going to do is size. What if the potato size when starting off is making it different compared to if I don't make it a big potato size? So I'm going to get the biggest potato I could find, and I'm going to leave it as a big chunk. So this is a lot bigger than my other potatoes before. But I still have to use 4 toothpicks because I've been using 4 toothpicks last time. So I want you guys to get your 4 toothpicks and do what we just did last time. Now, there is the possibility that none of these grow. So that is also what we need to take into account for. It's going to be very interesting if these grow or not. So I want you at home to make sure you look at it every day, and then what we do as scientists, we record what we see. To be honest, I don't think this one even needed. Oh wait, no, because I had to put it like that. There you go. Make a little small adjustment here. just like that. And I'm going to fill it up with water and place it in front of a light source, just like how I did last time. And now I need to get the same size potato as I did last time. Because if I got something that was small, it might not grow because it was small. I need to make sure that it was the big size that affected the results. We could also grow a potato in coffee versus tea. I like that idea. We're going to do that as our next one. So I'm just making my potato toothpick apparatus, like so, placing it on top of the cup, like so, and then filling it up with water. See, it's very, very important to write this stuff down though, because right now I remember that's a potato, that's an apple, that's light, that's dark, that's big, that's small. But if I come here in like a week from now and I don't remember what I did, I'm just going to see a bunch of potatoes in front of a windowsill. So that's why as scientists it's very, very important we write stuff down. But that's the boring part, so I'm going to skip that part. We next got a suggestion in the chat to compare coffee versus tea or coffee versus water. So I'm going to be comparing, I have coffee right beside me, if a potato could grow in coffee versus if a potato could grow in water. So I'm going to get my coffee and I'm going to pour my coffee. But I need to make a slight adjustment to my cup. I need to cut it so that it could be shallow enough for my potato to fit. So for everyone at home, I would recommend using enough coffee so that you do not have to do this. But if you have to, that's okay too. I just cut around the edges so that I have a smaller cup, but it's still the exact same cup, and I filled it up with water. Next, I'm going to cut a new potato. And I'm going to get my toothpicks, just like I did last time. So slimy surface on the bottom, and we're going to go 1, we're going to go 2, we're going to go 3, and then we're going to go 4. Then we're going to place it in our coffee, and then we're going to put it by a light source. So next, we have to do the exact same thing, but we have to do it regularly. So we're going to get our cup, we're going to get our potato, we're going to go 1, we're going to go 2, we're going to go 3, and then we're going to go 4. And then we're going to put it in our cup, and we're going to fill it up with water. And we're going to place it by the same light source. So at this point, we have different experiments running right now, and we also want to track how long it takes for us to notice a difference. So this is something that you guys at home could do. I'm going to be doing it as well every single day. You're going to look at your potatoes and you're going to look for any differences that you see on the potatoes. Now, where are the differences going to appear? We do not know. That's why it's up to you to be very, very careful and look what's going to happen. What if you put a potato inside a plastic bottle? Then you get more light and heat, so it would probably grow bigger more quickly. That is an awesome suggestion, and I was thinking the exact same thing, hensing the water bottle. So that is a very good hypothesis, and we even have a reason for it. So when you make a prediction or when you're guessing something for no reason at all, that's a guess. But when we have some information like that, that is the difference between a guess and a hypothesis. That is excellent, Natalie. So we're going to be doing that right now. We're going to get our bottle, and we're going to be cutting it so that we have a surface to work with. It's going to be a little tougher than I thought. There you go. So this is comparing the growing conditions between a disposable cup or the cup you've been using for all the past experiments and the plastic water bottle growing conditions. So we need our potatoes and we need to do 4 toothpicks because we need to keep everything as equal as possible. We're going to go 1 toothpick. We're going to go 2 toothpicks. We're going to go 3 toothpicks. Then we're going to go 4 toothpicks. We'll be placing it in our water bottle apparatus. See, my water bottle apparatus doesn't stand up straight, so I cannot be using that. I need to make a new one. So I'll be using the base. With this experiment though, it's very, very important that you use the water from the same water source you've been using versus the water in the water bottle. Can anyone think about why before I give the answer? If we're watching at home, I want you guys to think about the answer. If we use the water that comes in the water bottle versus the water we've been using in the past, why would that be a bad idea in this case? It would be a bad idea because those are 2 different sources of water. So if stuff happens that is different, we won't know, was it because we used a water bottle or was it because the water was different? So I'm going to be emptying out my water bottle and then filling it up with new water. Too much water. And then we're placing my potato. Let's see if it fits. Yes, it does. And we'll be putting it by a light source. The same light source we've been using. Very, very good. And then lastly, I'm going to be making one more to compare it, and I need to do the exact same thing I've been doing. Let's get my potato. Go 1 toothpick. Go 2 toothpick. This one's a little crooked. Let's make it straight. Go 3 toothpicks. And then go 4 toothpicks. Place it on top of your cup, and then we're going to fill it up with water now. And then placing it right by the light source. And now if you want to do it at home, get yourself a journal and write down what we are doing. I'm personally not going to do that. I think I might. You know what? No, I might do that because we're gonna look at these in 2 weeks from now to see if we notice any differences. So I'm going to jot down what I notice. So I might be doing that. And the purpose of this is because we want to look every single day and look for something new. There are a lot of potatoes here. If you don't have enough space at your light source and it's a little crowded and you don't want to have it there for a week, that's okay. But I strongly recommend that you leave at least one because I think we're going to see something very cool. I'm not going to spoil anything, but I think you're going to be very, very surprised with what we see over time. Or you might not. Who knows? That's why we're doing it. And then we have to clean up our workstation. I have a water cup here though, so we might be able to sneak in one more. I'm going to be comparing my potato. So I'm going to go 1. I'm going to go 2. I'm going to go 3. I'm going to go 4. And I'm going to compare this one to growing them outside. So I'm going to get this potato and I'm going to put it outside but right in front of my light source because it's going to be using the same light, but it's going to be using it comparing if it grows better outside versus inside. So I'll be filling it up with water. And now I'm about to take it outside. So that's going to end the science experiment for me. I hope you guys had an awesome time. And I'm sorry if I was using big jargon and I was explaining it too fast. But those are the terms that a lot of scientists use. So I'll go over it one more time really quickly so that we learn something awesome today. When two things are exactly the same except for one thing, say I get this toothpick and I get this other toothpick, but then I get a pen and I color on the toothpick, then they're the same except for one thing. That is called a variable. When we make a guess, that is what we call a hypothesis. And that is the terms I was using today, and I think I used one more, conditions. That's basically what is causing stuff to happen. And those are the terminologies that I hope you guys learned today. The words of the day, if you will. That's going to do it for me. Thank you guys. You guys are awesome, and I'll see you guys soon.